children. So what is the next one? An object is placed 40 centimeters. How much is that? An object is placed 40 centimeters from a concave mirror of focal length 20 centimeters. Object distance is given. Focal length is also given. So you are asked to find the image. Wait. No need to solve this. Directly don't take 1 by f equals to 1 by u plus 1 by u, because once look at the options, they haven't calculated. They are only asking whether it is a real, virtual, image, distinct, enlarged, magnified or anything. Okay. So first no need to solve it. So what is the object? Mirror is concave mirror. What type of mirror are they using? Concave mirror they are using. And where is the object? Object is at a distance of 2 times of focal length. F is 20, object is 40. So, object is placed at the radius of curvature. So, whenever an object is placed at the radius of curvature, children, one thing you remember that, okay. So, you will be getting a real image. Okay, you will be getting a real image only. Why? Because, okay, using concave mirror, you have a chance, you are having chances to get virtual image. But when? So, this is your focal length and let us suppose this is your radius of curvature. Whenever an object is placed in between focus and pole of a mirror, then you have a chance of getting virtual image. But whenever an object is placed before the focus point, whether it is between the center of curvature and focal point, focal length as focus point, away from the center of curvature, you always get a real image. Always get a real image. Okay. So, no doubt option C and option D are absolutely false. Okay. So, now, no doubt you are getting real and inverted image. But do you get the same size or the smaller size? So, whenever an object is kept at the radius of curvature, let us visualize this. Whenever this is your concave mirror, focal length, focus point, I'll say, center of curvature. Let us observe the light rays. A beam of light rays that are parallel to this. Okay, so this is your object. Beam of light rays parallel to this always passes through focus point. Similarly, the beam of light rays which are incident on pole again moves back the same point. Similarly, the rays which are going through focus will go straight. So, if you observe all these cases, then this and this meeting point will be, so image will be formed here at the center of curvature only. So, no doubt the size of the image remains same. Hence, the image so formed is real, inverted and as the same size. Whenever an object is placed at the center of curvature, remember that image formed will be real, inverted as well as same size of the object in the case of concave mirror. Okay, so answer is option A, that is real, inverted and same in size. So now moving to the 16th question, children, match the following. Some corrections are there, children. So if you observe this 1, 2, 3, third question, but there are fourth question is also given here. Okay, and even the fourth question is here. This option E is magnification is 0.33 must come towards the right side. So lot of corrections are there. First of all, let me correct it and then we'll check it out. Okay. So, what is that? Magnification is 0.33. I'll just remove here from here to avoid confusion. So, option E also you should take. How much is that? Magnification is 0.33. So these are 5 options it was given, children, and you have to match all the left side of the questions with the right side of the questions. Okay. So 1, 2, 3, 4 accordingly with A, B, C, D or E. So let us try to solve one after the other. So moving to the first question. So here we go. Position of the object is in list 1 and the magnification. This is the heading part. Again, you may get confused. So this position of object is given in column A and magnification is given in column B. List 1 and list 2. List 1 and list 2. So let us take the first question. An object is placed at focus before a convex mirror. So what mirror have they considered? Convex mirror. Okay. So consider a convex mirror. So convex mirror has a focus point. So again here also focus point. So an object is placed at focus before the convex mirror. Then what about the magnification so formed? So you have to find out the magnification value. Okay. So in order to find the magnification, you have to take m is equals to minus v by u, which is also equals to h2 upon h1. Okay. So solving that, we have first one. Find out the value of u is also unknown, v is also unknown. Object is kept at focus. But what about image? So in order to find out the magnification, first of all, you need to find out the size of the object as well as size of the image, or distance of the object and distance of the image. Then only you can find the, solve the problem. So first of all, first part, first one, let us try to solve only first one. General formula for magnification is m is equals to minus v by u, or it can also be taken as h2 upon h1. In the condition, object is placed at focus. So u value is given as f. Okay. Then what about the magnification? If you know the value of v, then you can find. So in order to find the value of v, first using the formula 1 by f is equals to 1 by u plus 1 by v, let us try to find it out. Okay. So what is the value? Here 1 by f, let us take it as it is. The value of u should also be equals to, object is also at f, focal length f. But it is in front of the concave mirror. Before a convex mirror, in front of the convex mirror is minus f. For a convex mirror, focal point is positive f, whereas in front of the mirror, object is kept at a distance of minus f. So bringing this minus f, 1 by minus f other side, 1 by f plus 1 by f is equals to 1 by v. So taking the LCM, we have 2 by f is equals to 1 by v, or v is equals to f upon 2. I think the space is not sufficient. Okay, I'll just minimize this. So what is this, children? 1 plus LCM is f and 1 plus 1 is 2 by f. If 1 by v, you are getting it as 2 by f. This implies v is found to be f by 2. The value of v is found to be f by 2. But you need to find out the magnification. In order to find the magnification, therefore, the value of f, m must be equals to v upon u. What is v? F by 2. What was u? F. Okay. So, simplifying this, we have, and are you getting positive or negative? Positive f by 2 you are getting. Okay. Formula for m is minus v by u. So, minus v by u is again you have minus f. Okay. So, solving this, f and f gets cancelled, minus and minus gets cancelled. Here we are getting it as 1 by 2. 1 by 2 is nothing but 0.5. So, the correct option for 1 will be, how much is that? 0.1. 1 goes good with 0.5. Option B. For first option, option B is correct. Magnification is found to be 0.5. I think the value signs are also clear. This minus, I considered it here. Okay. And V positive value you should get because it's forming a virtual image plus f by 2. And U is kept in front of the convex mirror, so minus f. So solving this, minus minus gets cancelled, you got it as 0.5. So it's all about the first part. Moving to the second part of the question. An object is placed at the center of curvature before a concave mirror. Then how would be the magnification? So where is that kept? At the center of curvature. In the previous problem also we solved this center of curvature problem with a concave mirror. So it forms an same size of the mirror but in the reverse ratio. But it's all about magnification. Okay. So if you remember that, you can directly apply, or else you have to solve for this, children. Where is the kept center of curvature? What mirror? Concave mirror. What formula? 1 by f is equals to 1 by u plus 1 by v. For a concave mirror, focal length will be minus f. Center of curvature. This u will be equals to concave mirror. If this is focal length, this will be center of curvature, and center of curvature will be at a distance of 2f, double of the focal length, and this is your object distance. So the value of u is nothing but 2f. Value of u is nothing but 2f. Which side? In front of the mirror, minus 2f plus 1 by v. Bringing this minus 1 by 2f, the other side you have 1 by 2f. I'll bring minus to the other side, plus minus 1 by f will give you the value of 1 by v. So this 1 by minus f, I wrote it as minus 1 by f. This carrying to the left side becomes plus 1 by 2f plus minus 1 by f. So simply let me write it as minus 1 by f. So this implies 1 by v is equals to LCM here is 2f. So this is 1 time and this goes minus 2 times. So finally you will getting as minus 1 by 2f. So how much you are getting, children? The value of 1 by v is found to be minus 1 by 2f, or v is found to be minus 2f. This implies the value of v is equals to minus 2f. But you are asked to find the magnification. Formula for magnification is minus v by u, and this is equals to minus of value of v is 2f, minus 2f, and value of u was also minus 2f. Solving these two, cancellation, minus minus 2f, 2f gets cancelled. So the value is found to be minus 1. How much is the magnification, children? Minus 1. A, B, C does not go with. So which one is the correct one? Where is minus 1? Minus 1 is somewhere here. So for the second option, option D must be true. That is magnification is minus 1. So let me write it here. The second option is minus D. So first option is B, 0.5. For second option is D, minus 1. Got it? So let us try to solve the next one, that is third question. An object is placed at focus before a concave mirror. So it's similar to the previous problem only. Earlier it was kept at radius of curvature, hence we took the value of u as 2f. But now it was kept at the focus itself. So u is also taken as the value of f only. So let us solve it in the next page. So solving here. Again, take the formula 1 by f is equals to 1 by u plus 1 by v. 1 by f is equals to 1 by u plus 1 by v, or 1 by f is equals to 1 by u. So where is that kept, children? It is kept at the focus only. So U is also taken as F, but before the mirror it is taken as minus F plus 1 by V. So what is that? Plus 1 by V. Is that clear? Well, so for a concave mirror, even focus point also should be taken as minus only. So bringing this to the other side, we have 1 by minus F plus 1 by minus F. How much is that? Somewhere. This is 1 by minus F plus this negative value when comes to the left side will become plus 1 by F. So how much is that? Minus 1 by F plus 1 by F, it is found to be 0. So clearly 1 by F is found to be 0, or V is equals to 0 is nothing but 0 by 1. Don't get confused. 0 is nothing but 0 by 1. Is all okay? So 1 by V is found to be 0. So 0 can be written as 0 by 1. Okay, that part is clear now. So if 1 by V is 0 by 1, then V is equals to reciprocal of that. The value of V is equals to reciprocal of that, and that is nothing but 1 by 0 by 1 by 0, and this is not determined, infinity, not determined. So clearly we found the value of V as not determined. So finding the value of magnification minus V by U. Instead of V, I have to minus, keep it here. Instead of V, I must replace it infinity. And U, object is kept at where? Object is kept at focus. U is taken as F. Infinity by anything, you get the value as infinity only, and minus symbol is already there. Hence, the correct option is nothing from here. Where is minus infinity? Yes, this one. Okay. So, third option goes good with option A. So, let me write it here as option A. So, clearly 1 goes with B, 2 goes with D, that is how much is that? Minus 1, and 3 goes with A, that is minus infinity. One more question is there. Fourth one. An object is placed at center of curvature before a convex mirror. We solved the same for concave mirror. Now it was asked for convex mirror. So let us look into that. Again, the same formula we'll be using. Yes. Lens mirror formula. 1 by F is equals to 1 by U plus 1 by V. Focal length for a convex mirror taken as positive must be equal to 1 by U. Where is the object placed? At the center of curvature. At the center of curvature means 2 times of F plus 2 times, minus 2 times of F plus 1 by V. Find out the value of V, children. Bringing this to the other side, 1 by minus will become plus, and already plus 1 by F is there. This will give you the value of 1 by V. LCM is 2F. This goes 1 time and this goes 2 times. So, this is equals to 3 by 2F. If the value of 1 by V is found to be 3 by 2F, then the value of V must be equals to 2F by 3. The value of V is equals to 2F by 3. But you need to find the value of magnification. Hence, the formula for magnification is minus V by U minus of V, just now we calculated as 2F by 3, and the value of U is taken as minus 2F. Okay, no doubt these 2 minus will get cancelled. 2F gets cancelled. So, you are left with 1 by 3 plus 1 by 3. How much is that? Plus 1 by 3. If you simplify this, 0.339, okay, something like this. So, what is the value of magnification? 0.33. So, fourth option goes well with E. Okay, so we have solved all the 4 questions. Now, let us check it out, the options. So, 1 is for B, 2 is for D, 3 is for A, and 4 is for E. So, option is B, D, A, E. BDAE. So first one BDAE. Hence, no doubt the correct option among them is first option BDAE. Clear? Okay. So with patient, you have to solve with patience. Apply patience for to solve such type of problems, children. Okay. Okay, children. Moving to the next question. That is